Nice to meet you. I'm Khatar Choktai and you're watching my YouTube channel School of Advanced Chemistry. I'm going to solve question number 2, October-November 2023 4-3 variant. Let's see how to solve this question. Question number 2, part A, define Kw mathematically by completing the expression. Kw is equal to H positive ion concentration multiplied by OH negative ion concentration that is given by the water basically. Part B, two solution V and W are described. V is HCl, W is NaOH. The concentration of HCl in V is the same as the concentration of NaOH in W. pH value of V and W differ by exactly 11.00 at 298 Kelvin. Calculate the concentration of HCl in V. So, first thing is that the concentration of both NaOH and HCl is same. It means that H positive ion concentration and OH negative ion concentration are quite pretty similar, are same in both solution. And the next thing is their pH. This is an acid, so its pH should be less than 7. It's an alkali, its pH should be more than 7. But the difference of the pH is exactly, 11 between them. So how to solve this question to find the concentration of HCl? Just have a look. We know that pH formula is minus log of H positive ion concentration. This is the formula of pH to calculate the pH of a stronger acid, usually normal acid. But if I'm going to find the pH of an alkali, then this formula can be written as, that is Kw over OH negative ion concentration. Here in this question we are going to have H positive ion concentration and it is equal to the OH negative ion concentration. Let the concentration of these both is equal to A. So H positive ion concentration is equal to A mole per dm cube. Let's suppose the OH negative ion concentration is also equal to A mole per dm cube. And the next thing, the pH of the acid and pH of the base are alkali. This formula is for acid, this formula is for alkali, to find the pH of alkali. The difference between these two pH is equal to 11. So for example, let's see if the pH of the acid, let pH of acid is equal to X and pH of NaOH or alkali, that's HCl, it's NaOH, is 11 plus X. So I can rewrite these two equations. Let's see over here. Number 1, X is equal to minus log of A. This is the A mole concentration, let's suppose for H positive ion, for OH negative ion. Now what is the next equation? The blue equation, this one. Here the pH is for alkali 11.x and it is equal to minus log of Kw. Its answer is 10 raised to power minus 14 at 298 Kelvin. And OH concentration, as you have seen, we have supposed to be A. So it's A. Now these, I can change this equation like that. X is equal to minus log of 10 raised to power minus 14 over A minus 11. Similarly, my X is equal to minus log of 10 raised to power minus 14 and minus log of A minus 11. These both equations, this one equation is equal to X for alkali and this equation is also equal to x. So these two equations will be equal to each other. I mean, minus log of a is equal to minus log 10 raised to power minus 14 minus log a minus 11. The answer of this portion is equal to 14 minus this one 11 minus log a. Here is already minus log a over here. So if I'm taking this minus log a towards left hand side, so minus log a minus log a is equal to 3. And you can see that minus 2 log a is equal to 3. Log a is equal to 3 by minus 2. I mean, divide by minus 2 on both sides. And finally, after taking antilog, a is equal to 0.0316. So this is the concentration of H positive ion, and similarly that is the concentration of OH negative ion. So finally we have calculated the concentration of HCl in this case. So the concentration of HCl is equal to 0.0316. Now, if you want to find the pH of the solution, I mean, if you want to pH of HCl, or if you want to the pH of NaOH exactly, then again, I mean, you can use it minus log of 0.0316, and here will be the pH, and for the pH of NaOH, you will use minus log of 10 raised to power minus 14 divided by 0.0316. So if you need, I think there is no need to find the calculation to find the pH of HCl or NaOH. There is direct answer, and this is the basic process or calculation for this step. Now come toward the next question, next portion, part 2. Equal volume of the two solutions V and W are mixed, giving solution X. Name the solution X and state its pH. Two solution V and W are mixed, their volumes are equal. For example, I am taking 10 centimeter cube of both, as they are having the same concentration. So if I'm taking the same volume, so their mole will be exactly same. And after mixing, they will neutralize themselves, and there will be no more acid or alkali in that solution. So solution X will be the salt solution, HCl plus NaOH, they will meet together to make NaCl. So there will be NaCl salt. So solution X will be NaCl, and pH of this NaCl is 7. That is a neutral salt, or it will be the neutral solution. Third part, 1 centimeter cube of 1 mole per dm cube HNO3 is added to 100 centimeter cube of solution X. Keep in mind that solution X is neutral solution, that is having 7 pH. If I'm going to add HNO3, that is almost 1 mole per dm cube, so it is a stronger acid. And similarly, 1 centimeter cube sample of 1 mole per dm cube is added to the 100 centimeter cube of the solution X, forming the solution Z. So solution Y, that is a mixture of NaCl plus HNO3. Solution Z is the mixture of NaCl and KOH. So estimate the pH of the mixture Y and Z, and no calculation is required. So if they are asking to estimate the pH, so very much simply, this is a stronger acid, its pH should be equal to 1. It's 1 mole per dm cube. And it's a stronger alkali, so its pH should be 13 or 14. So I am going to write it over here, 13. Part C, C1, this is propanoic acid, this is dichloro 2,2-dichloropropanoic acid, and this is sulfuric acid. They all are acid, suggests the trend in the relative acid strength of these three compounds. And explain your answer. First of all, the stronger acid is sulfuric acid. As you know, it's a mineral acid. So H2SO4, then there will be CH3C, Cl2, COOH, and finally there is the propanoic acid. Number one, what is the explanation? This whole trend is for 1 mark, rest of the mark are 2. So what is the basic explanation? H2SO4 is a mineral acid and it completely ionizes, or it is going to ionize fully ionized in water. Next thing, this one, dichloro acid, basically in this dichloro acid, Cl group, in dichloro acid, Cl group is electron withdrawing group that weakens the OH bond. And in the last one, in this case, the CH2 or alkyl group, CH3CH2, shows positive inductive effect. It shows positive inductive effect, and in this propanoic acid, OH bond is stronger due to or because of the positive inductive effect of this alkyl ethyl group. Now come toward the next one, part 2. When the concentrated sulfuric acid is added to the water, a series of acid-base reaction occurs. There are 3 conjugate acid-base pairs that can be identified during this series of reaction. So H2SO4, in first step, when it is allowed to react with H2O, it's a single step reaction. There is the formation of H3O positive ion and HSO4 1 negative ion. In second step, HSO4 1 negative ion, that is going to react again with water, and it is reversible step, and here is the formation of H3O 1 positive ion again, and SO4 2 negative ion is formed. In first step, this sulfuric acid, here is the conjugate acid, and here is its conjugate base. Basically, the pair of conjugate acid and base, are generally a pair that is differ by hydrogen ion. This pair is the conjugate acid conjugate base pair because they are differ by H positive ion. Then this is the conjugate acid base pair. They are also differ by just H positive ion. But this is the conjugate acid and this is conjugate base. Here it is conjugate base, it is conjugate acid. Acid is a species that is having more H positive ion or that is having less negative ions. Same is the case, these two species in next step, they are acid base species. It's a conjugate base, it's a conjugate acid, and so on. Now in the next step, basically in this next step, this HSO4 is in conjugation with SO4 2 negative ion. So in this case, this HSO4 is an acid because it is having more H positive ion or less negative ion overall, and this is the conjugate base. So overall, we are having this acid base pair, number one, number two, and this is number three pair. So I'm going to write, or I'm going to report my answer. So one is H2SO4 acid. Its conjugate base is HSO4 1 negative ion. Next conjugate acid is H3O. H3O, and here is water base. Conjugate base is H2O. Next conjugate acid is HSO4 1 negative, and its conjugate base is SO4 2 negative. Question number D, partition coefficient Kpc of the substance Q between hexane and water is 7.8 at 298 Kelvin. Q is more soluble in hexane than in water, and define the partition coefficient. What is the answer of, what is the definition of Kpc? It is the ratio of concentration of a solute when it is dissolved in two immiscible solvent. Ratio of a solute when it is dissolved in two immiscible solvents. Next thing is 5 gram of the Q is shaken with the mixture of 100 centimeter cube of water and 100 centimeter cube of hexane at 298 Kelvin and left until there is no further change in the concentration. Calculate the mass of Q dissolved in water. First of all, it has told us that Q is more soluble in hexane than in water. So the answer of Kpc, the expression of Kpc will be equal to solute dissolved in, the gram of solute dissolved in centimeter cube of oil divided by the gram of solute dissolved in centimeter cube of water, and its answer is 7.84. Now let's suppose the total value of the Q is equal to 5 gram. So for example, 5 gram is going to dissolve itself into 100 centimeter cube of oil. There is a 5 gram, and X is shifting into the water. So X over 100, for water, this ratio line mean division. So I mark divided over here. 5 minus X will be in the oil. Total is 5 gram. Let's suppose X is moving towards the water, and there is the expression 5 minus X over 100, that is divided by X over 100, and the whole answer must be equal to 7.8. So I can write it over here, 7.8, 5 minus X over 100 multiplied by 100 over X, so it will be cancel out. So 7.8 is equal to 5 minus X over X. So 7.x is equal to 5 minus X, and 7.8x plus X is equal to 5. 8.8x is equal to 5, and X is equal to 5 over 8.8. And here the X is equal to 0.5655 gram. So this is the value of the X that has been shifted towards water. Come toward the next portion. A sample of Q is shaken with a different mixture of water and hexane and left until there is no further change in concentration. It was found that the mass of Q dissolved in each solvent is the same. Use the Kpc value to suggest the possible values for the volume of water used and volume of hexane used. That the same mass of Q is going to dissolve in both cases. So they are asking to find the volume of water and the hexane. So Kpc is equal to X is the centimeter cube of hexane, hexane, and Y is the centimeter cube of water, hexane and water. So what will be this answer? So I can write Y over X is equal to 7.84. So Y is equal to 7.84x. If x is equal to 1, this one, then no, this one, then y will be equal to 7.84 centimeter cube. The last one portion, Q is more soluble in hexane than in water. It is suggested that Q is one of the KCl and this one butanol or methanoic acid. Identify Q and explain your answer. The first one thing is, if it is more soluble in water, so it means that if it is so once again, if Q is more soluble in hexane, not in water, so it means that it is having more or the larger portion of hydrocarbons. So that is water repellent. So this one CH3 CH2 4OH is the answer. It is the possible identity of the Q. It is having this one group, non polar group, that is showing van der Waals forces or no, that is showing specifically, basically, it is a non-polar and it is showing temporary dipole dash induced dipole forces. So it is not completely miscible or highly soluble with water. That's all about this question. Thank you very much. Please subscribe my channel, hit the bell icon and share it with your friend. Thank you. Thank you very much. Have a nice day.